Good afternoon, everyone. I'm Bansi,
I'm Vishal.
I'm Anj.
and today we are here to present our final project for visualization in machine learning. We've followed track 2, wherein we've created an analyzing tool to understand the behavior of Lime and SHAP explanations on different types of data, both synthetic and real world. The types of data that synthetic data that we've created are with noise and without noise. And within that, we have balanced and imbalanced classes with different feature correlations. We will show you the different explanations on the Streamlit app.
Okay. So for creating synthetic data, we have used a make classification method. So our first experiment that we have carried out is using synthetic data with noise and with balanced classes. We have created 3 features and 2 classes for prediction. Here is the feature correlation plot. Using this plot, we can derive Lime explanation between any 2 features using drop-down menu. From this, we can analyze that feature 1 and feature 2 has a highest correlation. So now we are checking Lime between those 2 features. So if we plot a Lime explanation between the highly correlated feature, we can get a higher probability on 0 class. And if we check it with the real-time row, it is also predicting 0 as the target variable. So in that case, Lime is predicting perfectly. So same goes with the synthetic data with noise, but with now this time it's with imbalance class. So we can choose any 2 features that is high correlated or maybe inversely less correlated, and check the same with the Lime explanation here, and also the sanity check from the row over here. So the third is synthetic data without noise, but with imbalance classes. The same goes here also. So now we are shifting our focus from Lime to SHAP explanations.
So for SHAP explanations, we have created graphs that are to summary plot and dependence plot. So first we create a summary plot for 2 definite reasons. That is like it is completely dependent on mean SHAP values, so which are also theoretically more rigorous and more intuitive. That means that it provides quantitative units for classification. So over here in this graph, if we select the model random forest and check the SHAP explanations for that, we can see that for feature 3, it is the most influential and impactful feature in classification of class 0 or 1. Same ways, if we select the drop down for feature 3, for dependence plot, we can see the vertical dispersion of SHAP values, which is due to the interaction effects with another feature, that is feature 1. So this means that it is not solely dependent on the fixed value, but also the values that are influenced by other features. So here examine the color distribution of feature 3. With interaction index feature 1, we can see that the values greater than 2 for feature 3 has increased. So that has positive values for SHAP values for feature 3. So with the interaction index, we can see that the values in the range from greater than 2.5, that is around 3, we can see for feature 1, the values which are greater than 2.5 and towards 3, there is an increase in the SHAP values, which we can see with the red dots. So this way we can check the SHAP explanations for different data sources, that is synthetic data with noise with imbalance class. Here we can see the vertical dispersion as well. If we select the synthetic data with different, so without noise with imbalance class, we can also see the proportionality and the improportionality, which is directly related to the correlations. So this way we explain the SHAP. So we provide the SHAP explanations. So the last is the without noise with imbalance class. We can see that it is highly proportional to the SHAP values. So hence now we move on to the real world data. We compare the synthetic data with it.
So for real world US Census data, we have given the user an option to choose which two features they want to use to train the model and then displayed explanations for them. So for instance, let's first take two features that are highly correlated. Family members under 18 and veterans benefits. When we select these features with high correlation, we see that the line is predicting class 0, which is the wrong classification. Now let's select features that has low classification, low feature correlation, I'm sorry. For this also, we see that the line is predicting class 0, which is again wrong. So what we observed is that when we're taking high correlation, the probability of predicting class 0 is still lower than the probability when low correlated features are used. But the prediction is wrong because the data is highly imbalanced. So line gives a wrong prediction irrespective of the feature correlation. Every instance will have different features that significantly contribute to the correct prediction. So line is highly unreliable.
So for Shapley explanations on real world data, here also we give the two graphs. We can see that weeks worked in a year is the most influential feature. And for that itself, like if we check the dependence plot, so over here, if we see that the values that are greater than, less than 20 for the weeks worked in year, have negative SHAP values, and hence for the greater values of interaction index in the number of persons worked for employer are associated with the decrease in SHAP values. So this way we can also analyze the SHAP explanations for real world data. Thank you. Do you have any questions?